All right. Good morning, my friends. Hello. Hi. How are ya? I hope you're doing well. Let's just do a little. Why not? I didn't do a warm up in my last class and it just felt weird. So we'll just do a little poll. How you feeling today? What's going on in the nucleus? And I'm going to post your work for today. Um, this name. I did not organize your Google Classroom. I did every other section I thought, but not yours. So
It's annoying that it doesn't do it for all of.
it's like so obnoxious. It's the most annoying thing in the world. So, all right. You guys think Google Classroom's annoying for you? Oh, it's the worst for teachers. It's horrible. Everything is bad, but that's all right. All right, my friends. So I am posting your assignment for today. It's gonna be a little bit like old school class today, where I'm gonna be talking a lot. There's a lot of info to get through today, and I'm gonna try to not do this. Maybe like once a week we'll do this max. Okay. And we're gonna be taking notes. And so what you're gonna be doing is I just clicked assign. While we are going through the Google Slides, I'm going to be screen sharing here on Zoom. As we are doing so, I recommend that you fill out your notes. So everybody should have gotten a copy of this, types of chemical bonds. This is going to be our synchronous work. We're going to fill out this information together in class. And then your asynchronous work is going to be putting it to the test and doing 5 whole practice problems. I only had time to type up 5, so we're only doing 5. Okay. And so if you feel like you're capable of taking notes and watching the Zoom call at the same time, go ahead and do so. If you feel like you need to focus and if you end up opening 2 windows, YouTube might pop up or like the gaming websites might pop up. If you feel like you need to focus just on the Zoom, that is fine because the slides are already on Google Classroom. I'm actually going to pull them up to the top. I'll have them floating at the top always. So that way, as soon as you go to classwork on Google Classroom, you will be able to see them right on top. Okay. So our current unit slides, I'll keep floating at the top. I'm doing something I used to do with my slides in the olden days. And what you'll see on the slides is a table of contents. And so you'll notice today's date, December 2nd. You can click that and it'll take you right to today's slides. Okay. So here's what we're doing today. If we look at the poll, we got 10 neutrons, 6 protons, and 1 little old electron. And we have a few of us remembering that in the nucleus, we have protons and neutrons. Not all of us, which is a little concerning, but that is okay. Okay, inside the nucleus, we have protons and neutrons. All right, very good job, my friends. We are going today to go over what you learned in the Ed Puzzle yesterday. In the Ed Puzzle, Tim and Moby taught you about some of the common types of chemical bonds. They talked about 2 of them. There's actually 3 of them. And by the end of class today, you are going to be able to look at any 2 atoms and identify what type of bond will form between them and how they form that bond in terms of electrons. Okay? So we had a lot to get through today. There are 3 main types of chemical bonds: covalent, ionic, and metallic. We are just going to be going through the basics today of each one. This unit is my longest unit of the year, and so we will be going through them one at a time. We're actually going to go backwards. We're going to do metallic, then ionic, then covalent. But don't worry about that for right now. In general, a chemical bond is going to involve energy and, most importantly in this unit, the interaction of electrons with the atomic nuclei. So we have 2 atoms here that are doing stuff with their electrons. Here it looks like they're having electrons at the dinner table. Here it looks like one's proposing with an electron. And here they're playing baseball with electrons. And so we're going to learn what those pictures represent today. Okay. A lot of this information should be review from your Ed Puzzle yesterday. If you have not done it, please do it. It is not just assigned as busy work. It's assigned as an assignment for you to be able to kind of think about it for yourself, take the time that you need to understand the concepts we learn in these very quick 20 minutes lessons in class. Okay, so please do it if you have not already. We learned yesterday, and we've learned kind of for a while now, that the ultimate goal for most atoms is to have a stable electron configuration. They are going to do this by following the octet rule, by bonding with other atoms. Okay, and they want to end up having the same electron configuration as the noble gases. The noble gases, we've already talked about it. They're fancy. They already have the full electron shells. They don't need to do anything to fulfill the octet rule. And so in the Edpuzzle yesterday, there was a word described that was used to describe these gases. I just put it in the chat. It said that these gases are inert gases. Can somebody tell us what the word inert means? You can type your answer in the chat. You can raise your hand, or you can, yeah, those are your two options. You can type your answer into the chat just to me or to the entire class. What does it mean to be an inert gas, or an inert anything, I guess I should say. All right, they don't move. They are stable. Getting close. We're getting close. Think about what unit we're talking about. Chemical bonding. Sean, very good. They won't bond. Okay. Why are they not going to bond? Why are these atoms not going to bond with other atoms around them? Very good, George, because they already have their full shells, okay? And so we talked about that in the sense that they're not going to gain or lose electrons, okay? Imran says yes, he agrees, okay? They already have the correct amount of electrons, so they don't need to bond. And what that means in the real world, they are inert, meaning they do not react. They are not going to have explosive reactions with water. They are not going to corrode and form into rusty metals. Okay, these atoms, they just are what they are. They're happy. They don't got to do anything. They just hang out. Okay, and so inert means unreactive. They are not going to form chemical bonds, and they're not going to do chemical reactions. Okay, all the other atoms, in order to become like the noble gases, remember, they're not becoming the noble gases, they're becoming like them. They do have to do chemical reactions. Okay, and that means forming chemical bonds. Okay, and so we're going to go through the three main types: covalent, ionic, and metallic. And again, as we do so, if you just got here or you were a little bit late, as we are going through this, you are encouraged to fill out this worksheet, which was just assigned on Google Classroom. If you want to just watch the lesson and fill it out during your asynchronous time, you will have time to do that as well. But we're going to go through and fill this out. And what we're looking for each of the types of bonds is how they bond in terms of electrons, what types of elements form this bond. And when we're talking types of elements, we're talking metals versus nonmetals. A couple of other key words used to represent these bonds, and then an example. This part is up to you. You can type the name or you can insert images from Google, whatever you need to do to get some examples that you recognize into these three types of bonds. Okay, we're going to get started with covalent bonds. Does anybody remember from the Edpuzzle yesterday what is going on with the electrons in a covalent bond? Very good, Jason, you're quick. They are being shared. That is correct. That is correct. Okay. And the way I remember this is the prefix co. Okay. If you co-own something, you share ownership. If you co-work with somebody, you share the work. They interact with each other. If you cooperate, you are working with each other. Okay. And so a covalent bond is going to be atoms that are sharing their electrons. Okay. So on my notes, if you're filling them out with us right here, I'm going to write share electrons. You can format this. You can make the text bigger, the font, whatever you want. Do your thing. Okay. They are going to share electrons. The types of atoms that are going to want to share electrons are going to be atoms that want, and those are going to be nonmetals. Okay. Nonmetals are typically going to be the atoms that will want to gain electrons to fulfill the octet rule. So if they're working together, they're forced to share. So covalent bonds occur between two or more I keep spelling or, metallic ors, nonmetals. Feel free to abbreviate nonmetals as NM. That means nonmetal to chemists. To me, it's the state I grew up in, but I'll know what you're talking about, okay? And they're also called molecular bonds. You guys have probably heard the word molecule thrown out around all the time, but little did you know, the word molecule is only attached to atoms that are covalently bonded to each other. Okay, and so you have probably talked about water molecules, and that's going to be our first example. Here's a little example of a water molecule in which two hydrogens work together by sharing electrons with one oxygen to make the stable compound, although it sounds scary, dihydrogen monoxide. Did I bring back some drama from 2 days ago? Okay, so other keywords, molecular compound. Which of the following is a molecular compound? It's going to be the one that is covalent, sharing electrons with two or more nonmetals. Okay. So examples, we have, oh, by the way, the little picture, see they're sharing electrons at the dinner table. We got like family style going on. They're sharing. Okay. Water, dihydrogen monoxide, has two hydrogens, nonmetals, bonding with oxygen, nonmetal. So there's the check, two or more nonmetals, and they are going to share electrons. In these diagrams, this line, we're going to learn how to draw these from scratch in this unit, but this line implies that two electrons are being shared between these two atoms. Okay, and so water, hydrogen and oxygen, both being nonmetals, are going to covalently bond by sharing electrons. So you can write, Ms. Garcia, you can write water. If you want to write the chemical formula, great. How I am getting the two to be little is using control comma, and it will get you in the subscript. To get out of the subscript, you can just hit it again. We're all going to learn how to do that, so get used to it, okay? But again, control comma to get that subscript, okay? So water is an example of a covalent molecule. Another example is carbon dioxide. This is one that you all should have heard of. This is one that everybody can make right now by going, does anybody know the symbols for carbon dioxide? This is going to be called a chemical formula. So like water's is H2O. Ooh, we got them quick today in the chat. Carbon dioxide is CO2. Glad we're remembering some living environment because yes, it's all related, okay? And so carbon dioxide, we have one carbon, a nonmetal, bonded to two oxygens, dioxide, two oxygens. We're going to learn how to translate that in this unit. Nonmetal, nonmetal. If there are two nonmetals, we know they are sharing electrons to form a covalent bond. This picture here, all these dots in between the letters are going to be shared, and we're going to learn how to draw these here. The last picture, they were sharing 2 electrons. Here, they're sharing 4 and sharing 4. This is one of the more complex molecules, but we'll learn how to do that all in this unit, okay? So that is our second example. You can write carbon dioxide. You can not, that's not how you spell it. Or you can add pictures from Google, whatever you need just to get some examples up there, okay? Second type of bond is going to be ionic bonds. Does anybody remember what is going on in terms of electrons in an ionic compound from what you learned yesterday? One of them takes, lose and gain. There you go. Dean got the word that Regents likes to use. They are going to transfer, okay? Think of the root word of ionic. It is ion. To become an ion, an atom will either gain electrons to become negative, or it will lose electrons to become positive. And so an ionic bond, you have one of each. You have one atom that wants to give its electrons away, and then it's going to give them to somebody who wants to take them. Okay, and so an ionic bond is going to be characterized as the transfer of electrons. Okay, spoiler alert, the atoms that want to give electrons are always going to be metals. If you look at any metal on your Regents periodic table, you will notice in the top corner, they are all positive charges. That's because that's all metals want to do. Metals just want to like get rid of those electrons. They're like Marie Kondoing their apartment. They want to get rid of them and say goodbye. Non-metals, on the other hand, are maximalists like Miss Garcia. I got a lot of stuff. They're like, give me the electrons. And so they work together. You will know you have an ionic bond, a transfer of electrons, if your two atoms are one metal and one non-metal. Okay. In the reading that I typically give for this lesson in the olden times, there's an other word used for ionic bond. It's kind of like old school. If you're talking to a fancy British chemist, they might use this. But occasionally they are referred to as electrovalent bonds, in which the valence electrons are moving around doing their thing. But that word's not used that much. But in case you see it, you can remember this one moment in time that it's also referred to as ionic bonding. Okay. If we look at our little picture here, we have the metal proposing to the non-metal, giving that electron away to make everybody happy. Okay. All right. So examples, table salts. Does anybody know what table salt's chemical formula is? What is involved in table salts? I know if you're in person, we have talked about this, but what is table salt? Do, 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 do. Very good, close. Yeah, Andy, I think you got it, but you got the symbols a little weird. It is sodium bonded with chlorine. And sodium, there you go. Sodium is Na and chlorine is Cl. Okay, the official name for table salt is sodium chloride. Okay, there are an infinite amount of salts, but this is what most people think about when they hear the word salt. We have one sodium that wants to get rid of an electron, bonding with one chlorine who wants to take. And so what happens if you eat a lot, you explode. Don't try that experiment at home, okay? But you could get cardiac disease, and that's not good. And yeah, salt, you do need to live, but too much, it's like, nah, it's not gonna work out. Okay, heart attack central. Anyways, sodium wants to get rid of that electron, chlorine wants to take. And in doing so, sodium becomes a positive ion, chlorine becomes a negative ion. So they make an ionic bond. Okay, I like salt, right? Don't we all? French fries, salt, all that good stuff, but all in moderation, you're good. Okay, so here's the most common example people think of when they think of ionic bonding. Another example, magnesium oxide. I don't know why. This helps protect cardiovascular system. So if you eat too much of that other salt, this salt will apparently help you. Okay, and this one is showing how sometimes you transfer more than one electron. Here, magnesium wants to get rid of two, and luckily oxygen has room for two. So this 1-to-1 ratio works out. Magnesium gives two electrons and oxygen takes them. Okay, so there is another example. You probably never heard of this, but that's okay. You want to hear a joke? Did you hear that magnesium went on a date with oxygen? I was like, OMG. So funny. You get it? Miss Lee's laughing. Next question. All right, the last one. This is probably new because Tim and Moby did not talk about this one. But right now you should have covalent filled out, ionic filled out, and then metallic we're going to fill out pretty quickly. There's not much to it. Ionic metallic bonding, you could probably guess from the name what's going on. But in a metallic bond, you have metals that don't want electrons, okay? And so if you have things that want to get rid of electrons, very good, Imran, you got it. They're going to form between metals, okay? We have atoms that don't want these electrons. They want to get rid of them. You can imagine them as playing like a game of hot potato, or here they're playing baseball. They're constantly throwing them back and forth between each other. We have the gray circles here representing the metallic ions, and then these red electrons constantly flowing in and out from each other. Spoiler alert, this explains all of those metallic properties like malleability, ductility, conductivity. We'll talk about that later though, okay? And so officially, this is going to be referred to as a sea of electrons, where they are constantly moving around from atom to atom. So on my notes, I'm going to write sea of electrons, sea as in the ocean, okay? They're constantly moving and flowing in and out, okay? As Imran said, this is going to be just between metals, okay? If you have two metallic atoms next to each other, they all want to get rid of their electrons, and so they will constantly be throwing them back and forth. Another way to describe this is mobile electrons, the word mobile meaning movable. And so you have electrons moving in and out of each other, okay? A little picture here, they're playing baseball. I don't know why they have a hoop when they're playing baseball, but whatever. We'll let the atoms do their thing, okay? And so metallic bonding, an example that you have probably all heard of is something like brass or bronze. Brass is going to be a mixture between copper atoms and tin atoms, where they are put next to each other. They form metallic bonds. It makes them stronger than their independent elements by themselves. And so that's why oftentimes we want things like brass, steel, bronze. These are all metals you've probably heard of, but they're not on the periodic table because they're actually mixtures of a bunch of different types of metallic elements. Okay? We did it again. We ended right on time. Here are the 3 main types of bonds, okay? And you should have them filled out on your notes. If you don't, these notes are already available to you on Google Classroom, so you can use them. Yes, very good conductors for metallic bonding. We'll learn why this type of bonding results in that property. But what you're going to be doing for your asynchronous work today is, if you have not already, you're going to complete the top of this chart. And then at the bottom is your practice. I've done one example for you. You have 5 compounds between 2 atoms. These are going to be called binary compounds between 2 different elements. What you're going to do is you're going to tell me the first element type. So for example, water, hydrogen is a nonmetal. You can ignore all these numbers for right now. Just look for the elements. Second element, oxygen, is a nonmetal. I know from my notes that 2 nonmetals make a covalent bond, and that means the electrons are shared. Okay, and so that is all you have to do for your asynchronous work today, is make sure that worksheet is completed. You can turn it in. I'm going to return it as soon as possible, so that way you have it available to you as notes, because yes, we're going to keep asking these questions for the next foreseeable future. I don't know how long this unit is going to take, but these are the basics. All right, that is all I have for you today, my friends. If you want to stick around and ask some questions, I have about 5 minutes. Otherwise, you are good to go. I recorded this lesson, so I will have it posted here in a little while if you want to rewatch it. I need to edit it a little bit. But otherwise, have an excellent Wednesday, and we'll see you tomorrow.
Have a good day.
Bye, Naomi.
Bye, everyone.
Bye, Sean. Goodbye, goodbye, goodbye.
Bye.
Bye, Chris. Goodbye, John. Goodbye, Imran. Goodbye,
Bye.
Sean. Goodbye.